Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic probability. In the previous video, we learned about the definition of some terms used in probability. In this video, we are going to consider another term, event. Event is a collection of sample points with a common property. It is a subset of the sample space. We learned about sample space in the previous video, and we learned that it is the collection of possible outcomes of an experiment. The members or elements in the sample space are called sample points. Now, a collection of these sample points using a common property is what we refer to as events. Let's consider this example. When a die is cast, the possible outcomes are 1, 2, 3, 4, 5, 6. We learned this in the previous video that when you cast a die or when you roll a die, the sample space or the collection of possible outcomes are 1, 2, 3, 4, 5, and 6. Now, if the event of throwing an odd number is E, that is, the collection of odd numbers in this sample space is E, then E is equal to 1, 3, 5. So you can see clearly from here that we selected 1, 3, 5 from this sample space. So the event of throwing an odd number, which is E, is the collection of odd numbers in this sample space. That is why we say that an event is a subset of the sample space. So when you have a sample space and you collect some of the members in the sample space, that is the sample points. When you collect some of the sample points using a common property, that collection is referred to as an event. So here the common property we are using is odd number. So we are selecting odd numbers in this sample space and they are 1, 3, 5. So if this is the set of possible outcomes, then the event of throwing an odd number, which is E, which is given as E, is the collection of odd numbers in the sample space, and we have E as 1, 3, 5. In the previous video, we said that the sample space is a set because it is a collection of numbers with a common property. In the same way, an event is also a set because it is a collection of numbers with a common property. Let's consider the types of events that we have. The first type of event we are going to consider is certain event. Certain event. A certain event is an event which contains all the members in the sample space. A certain event is an event which contains all the members in the sample space. Let's take this as an example. For example, getting a head at the toss of a coin with two heads. We learned in the previous video that a coin has two faces, the head and the tail. But let's say that we have this coin and the first face is a head. The second face is also a head, not a tail. So this coin has two heads. The first face is a head and the second face is a head. Now when you toss this coin, the sample space, which is the collection of all the possible outcomes, will be a head represented by H. Because when you toss this coin, you are only going to get a head. Whether it falls on the first face or the second face, you are going to get a head. So the possible outcome is a head. The event of getting a head is also a head. The event of getting a head is also a head. So in this case, the members in the sample space and the members in the event are all the same. A certain event is an event which contains all the members in the sample space. So when all the members in the sample space are also in the event, then that event is called a certain event. Surely that event is going to happen, because here we can say for sure that when you toss this coin, you are going to get a head, because the first face is a head and the second face is also a head. So a certain event is an event which contains all the members in the sample space. The second type of event we are going to consider is the impossible event. Impossible event. An event which does not contain any sample point. An event which does not contain any sample point. Let's look at this. For example, getting a 7 after rolling a die. We learned in the previous video that when you roll a die, the sample space is 1, 2, 3, 4, 5, and 6. So when you roll a die, the set of possible outcomes are 1, 2, 3, 4, 5, and 6. Now, the event of getting a 7 after rolling a die is an empty set. In the video on sets, we learned that an empty set is also referred to as a null set. So when you roll a die, the event of getting a 7 is an empty set or a null set. It's an empty set because 7 is not part of the possible outcomes. That is, 7 is not part of the sample space. So when you roll a die, you can't get 7. So an impossible event is an event that does not contain any sample point. So you can see from here that because 7 is not part of the sample space, the event of obtaining a 7 or getting a 7 does not contain any of these sample points. So it's an empty or null set. When you have such an event, it's called an impossible event. An event that does not contain any sample point. That is an event that is empty or null. So we've learned that for certain events, all the members in the event are contained in the sample space. But for impossible events, the event does not contain any of the sample points. The next type of event you are going to consider is mutually exclusive events. Mutually exclusive events. Two events that cannot occur together. If two events cannot occur together, they are referred to as mutually exclusive events. For example, getting both a head and a tail at the toss of a coin. We know that for a fair coin, it has a head and a tail. So one face is a head and the other face is a tail. When you toss such a coin, you can't have a head and a tail at the same time. The coin will definitely land on only one of them. So it's either it will land on the head or on the tail. So when you toss a coin, you can't get a head and a tail at the same time. So the event of getting a head and a tail at the toss of a coin is what is an example of a mutually exclusive events. Two events that cannot occur at the same time. Another example is winning and losing a football match. In a football game, you can't win and lose at the same time. So two events that cannot occur together are called mutually exclusive events. The next event you are going to consider is independent events. Independent events. Two events are said to be independent if the occurrence of one does not affect the occurrence of the other. So two events are said to be independent if the occurrence of one does not affect or does not depend on the occurrence of the other. Let's consider an example. The event of getting a 4 at the first roll of a die and getting a 2 at the second roll of a die. Let's say that you are rolling a die. The first roll you get a 4 and the second roll you get a 2. Getting a 2 at the second roll does not depend on getting a 4 at the first roll. So the number that you get when you roll the die for the second time does not depend on the number that you got when you roll the die the first time. So these two events does not depend on each other. So they are called independent events. So when you have two events that the occurrence of one does not depend on the other, then they are said to be independent events. For mutually exclusive events, they cannot occur together. Independent events are such that the occurrence of one does not depend on the other. We will be using these types of events a lot in our studies on probability, so make sure that you understand them very, very well. Thank you for watching this video. Subscribe to this channel for more videos. So far, we have considered the definition of some terms used in probability. In the next video, we are going to consider how to find the probability of an event. We will also learn about the laws of probability. Bye-bye.